All right. So, this presentation has some slides, but given that I've just changed it off and Andrew was away, it's a little bit chunked together, so feel free to jump in and make it a bit more interactive. So, who are we? You can go first. You're first on the slide.
So, for anybody who doesn't know me, I'm the principal consultant at Redify. Unofficial title is, as you can see, the Chief Asker of all my questions. I tend to be the one to ask why the Emperor isn't wearing anything, which is one of the things that we're doing this evening. Asking, not wearing.
Yes. And I'm Damien. I'm not Redify anymore, but that's a fairly recent thing. Most people know me as Redify. I recently joined an Octopus Deploy with a very grand title.
Then you unsold it to Redify clients.
Sorry?
Then you unsold it to Redify.
No, unsold it to Redify clients, and that's why I have the job. No, I've joined Octopus. I've known Paul for a very, very long time, and you know, I think it's a great product, and I've been using it for a very long time. That's why we unsold it, because it's a lot easier than zipping up or creating an MSI file, writing a Word document, emailing it to some ops guy who unzips it, builds their own MSI, and then manually copies it onto the server and screws it up. Not that not that I've seen that happen at all. So that's us. Not that we're fairly notorious anyway. So the talk tonight, we're going to talk about messaging patterns. We're going to talk about microservices. We're going to talk about service buses. And whatever else comes up. I'm sure you're going to heckle us mercilessly, and I'll give it back as hard as I can. Because I love the Queensland government. So I'm going to hand it over to Andrew to begin with. Got that?
Does this one have a laser?
Yes, pew pew pew.
Excellent. Oh, you've got a red laser, that's really cool.
I am your father.
Well, mine has a green laser. It's all very different.
I see you've constructed.
All right, so messaging patterns. Now, just a quick show of hands. Who was at DDD Brisbane last year? And it's very similar to what we have everywhere. Okay. So we're going to cover some of the same content. It won't be identical, but basically what I'm going to try to do is give you a really quick overview of what a service bus is, why it's a thing, what kind of messaging patterns we care about, so we've got some fairly consistent terminology. This isn't so much about the messaging patterns themselves, I just want to make sure that we're starting from a common base. So, messaging patterns. What is a service bus? Who can actually give me a definition of a service bus?
Don't say this to
Okay, so a service bus you can think of as a shared broadcast medium, kind of like the old days before we got programmed switches. The key being that we kind of want to perpetuate the idea of agnosticism about who we're actually communicating with. So a service bus is about what can you do for me or what can I do for you. It's not about who I am or who you are. Okay? In most cases, what I want to do on a service bus is send an instruction, ask for thing to be done for me, ask a question, or I want to just say, hey, tell me when a thing happens. And I kind of don't care who I'm talking to. I don't want to know. And I guess that's the key. I actively don't want to know. It's not service discovery. It's not, hey, where can I find the endpoint for such and such? It's, please don't tell me the endpoint for such and such. Just do everything for me. So we've kind of got three main constructs, but they're all based around messages. They're just messages, and at the end of the day, messages can be one of two structures. We're either talking a set of key value pairs, or we're talking some sort of serialized object. In this case, we care more about object serialization, but we'll look at both. Now, you know what a queue is? Who does not know what a queue is? Okay, who knows what a durable queue is? Who does not know what a durable queue is?
Who's just shy?
Who thinks they probably know the answer but are really, really afraid that I'm going to heckle them horribly? And all the hands go up. Okay, so As far as a service bus, or as far as any kind of messaging infrastructure is concerned, we care about the concept of a queue because pretty much everything is built around the concept of a queue. Whether it's an eventing subscription system or a request or response or something, everything is pretty much queue-based. So queues, as far as service bus is concerned, are FIFO, mostly, first in, first out, with exceptions for things like messages that go boom on the other end, but we'll talk about that if we have time. So if we have poison messages, then we don't really guarantee. So it's kind of best effort FIFO, so don't really trust it. Anyway, we'll come back to that. They are durable, which means they promise that when they say they've accepted your message for delivery in that queue, it has been written to disk somewhere. Not quite sure, excuse me, not quite sure where somewhere is, and again, we don't care, but if we say to some sort of thing that promises to be a durable queue for us, could you please put this message in your queue, it is not allowed to come back until it's promised that it's written it to disk, flushed the buffers, done everything else, it is actually on durable storage. So if we have a power failure, we're going to get that message delivered somewhere.
Which is why building messaging system on MongoDB.
It's fine right up until you actually use it. So, no questions about queues?
No, that's Raven. Sorry.
Oh, we're going to alienate the NoSQL.
There's another verified person who swore by Raven, even though that's at the version 2, the index.
In certain contexts, it's great.
In some contexts, it's wonderful. If you have a high insert load, its indices will just never come back to that. Like, they'll just never catch up.
I think the indexing is counted by one stage, and then the other releases as well. Index count.
Yeah, I've played ones. We've never seen those before in computer science. Okay. So no questions about queues? Okay, good. Excellent. So the first thing that we care about in a service bus is being able to subscribe to events. Now the reason that we care about this is for decoupling, a whole bunch of other reasons that we'll come to soon-ish when we get to what does this look like for realsies, because we'll be doing most of that. But what we care about is events and telling you when a thing has happened. So I need to be able to say to some service busy thing, hey, could you please tell me when something happens? And again, I don't care who's producing that event or where it came from or why it happened. I just care that when this thing happens, could you please tell me? So is my inventory running low? Just tell me please when I'm starting to run out of the thing. I don't care why we're going to run out of the thing. I don't care if it's because we've sold all of the thing, or the thing is perishable and it's gone off, or we've had a gigantic flood and we've lost a warehouse. All I care about is we're running out of a thing, so perhaps I should order more or do something else. But the key is I don't care why that event happened. I just want to know that it did happen. I don't care where it came from. I just want to know that if I ask to be told about a thing, then I will be told when that thing happens, and I can do whatever it is that I want to do. Okay. So publish and subscribe. Now, as a producer of an event, I don't care, I actively do not want to know or care who is consuming my events. Okay? I publish an event and I go, right, you lot, sort yourselves out. Okay? I don't want to know who is subscribing to my events. Okay? One of the fundamental principles of PubSub, it's the reason we have PubSub, is to decouple the two. Does that make sense? Is there anyone that this is kind of new-ish to? A little bit? Okay, a little bit. We'll stick with that, that's all good. Okay. Now, the next thing is a command. So we've got an event, publish, subscribe. The next thing we care about is a command. Now, command is pretty much the only thing that should actually change the state of our system. I'm going to put an asterisk on that, but for the most part, it's pretty much the only thing that should change our system state. And a command is pretty simple. Do a thing. I'm not going to sit there and wait for you to do that thing. It's going to be completely asynchronous. I just want you to do a thing, go away. I don't care about feedback. If I do care about feedback, then we can look at some other back channels later. But for the most part, a command says, do this thing, is fire and forget, and pretty much everything that we need in order to have that command dealt with is encapsulated within that command object. So in this case, we want to send an email. Send an email to someone that's probably going to be something along the lines of we've got a sender and recipient and a subject and a whole bunch of other stuff. Or maybe I'm just going to say, hey, send a welcome email to subscriber number, whatever the new person is. But whatever it is, that command should be able to be handled in isolation. It shouldn't need any preceding state. It shouldn't need to know about the state of the universe. It should be able to figure everything else it needs out for itself. Now, that's really important because we need to be able to scale this. Now, we'll come to scaling a lot later, because if you're not going to scale, then that takes away one of the key reasons for using a in the first place. There are others, but that's one of the key ones. So what we can do, if we look back at this guy, what we have here is some application that's spitting out a bunch of commands. And for the sake of argument, because we don't want to explain the actual business domain, it's sending emails. Okay, fine. So it just says send an email to Fred or whatever. And our email service just sits there and chugs away. Now, because this bit is a FIFO queue, pretty much, when a command goes onto this queue, it just goes and travels all the way down to the other end of the queue, and someone pops it off at the end of the queue and does a thing. What happens when this thing gets swamped? What happens when that thing falls down? Firstly, does this entity here, does this application care? Should it care? It really doesn't want to care. Okay, this shouldn't care. This, for the sake of argument, we are going to assume can be infinitely big. Okay, we're going to say, for the sake of argument now, that we can have a queue that's infinitely large. This is going to drop a message. In reality, most of your messaging systems will be about 5 gigabytes worth of queue size. If you fill up 5 gigabytes worth of single queue with commands like that, you've got a lot of email to send. But at some point, this thing's going to need to be rebooted for maintenance, or we're going to need to scale it up or scale it down, or it's going to fall offline, or maybe our outbound SMTP gateway falls in a heap work, or we might want another one. So we spend another couple of them up. And that's our producer and competing consumer, or command and competing consumer pattern. And what that allows us to do is have these 3 instances of the same thing compete to pop messages off the queue. Now remember, this guy here doesn't care about who's consuming these messages. And these 3 services here don't care about anything other than give me the next message, I'll do what it says. Give me the next message, I'll do what it says. If I want this to go faster, I add more of these. There's quite a nice platform where we can just drag a little slider and say, I'd like things, please, and it's called version of these things. Does that make sense?
See what just made it relevant?
Wasn't that a great time? Anyone would think that we had a sponsor or something. Okay, now we care about PubSub. We've gone through PubSub a little bit before, but basically we've got an application, it publishes an event. So we're selling some stuff, we've got an auto-confirmed event. Now the application just publishes that event. It says, hey, I sold a thing, confirmed it, the customer, I've told the customer that it's in the mail. And we've got a bunch of different systems that care about that. We might, for instance, have a logistics service here that cares about actually shipping some stuff. Hey, so we sold a widget, we sold a book, we sold whatever. We should probably actually get that to our customer, because that would be nice. We also want to record what our customer has bought, and we want to record that over time, because maybe we want to feed that to a recommendation engine or something completely hypothetical like that. And of course, we would probably like to send an email to the customer to say, hey, we've actually got the money here, and these things we promise. Now, we may well want to attach other behaviors here. We may want to do things like inventory level checking or who knows what. But the key is, my application that's publishing this event should never know. Shouldn't know, shouldn't care. As far as it's concerned, hey, the order is confirmed. Anybody who cares, okay, do what you want. Now, this one is a little bit of a sharp edge. Request and response over a service bus is kind of the subject of a religious debate. I'm not going to get into that debate tonight. If you want to go and read up on it, by all means, go and read up on it. I will say, however, that at some point your application will have to ask a question and wait for an answer. That's all there is to it. What is the exchange rate between Australian dollars and US dollars? And I can't do this calculation without that piece of data. Okay, so I have to just wait. Now, you do want to use request and response really, really sparingly. Okay? In a lot of cases, what we'll see is people using request and response and stuff when what they really want is a command. Okay, and a command followed by a series of events or something along those lines. But as a general rule, the first time you reach for request response, put it down again. Your requests and responses should not change the state of your universe. Now there are some very, very edge cases where maybe that's okay, but step away from the sharp tool. Okay, you ask a question, you get the answer. Asking that question should not change the state of the universe. Okay. However, one of the advantages that we get from using a service bus for this rather than just a straight REST call or WCF call or SOAP or whatever. So, why does SOAP make people feel dirty? Anyway. I don't care who answers that question for me. I genuinely do not want to care. It's not that I just don't mind not knowing, it's I actively do not want to know who is providing the answer to this question for me. Okay? So if we're looking at give me the customer's purchase history. Okay. I don't care where that comes from. I don't care whether that comes from our dedicated customer purchase history service. I don't care if that comes from a forward checking service. I don't really care where it comes from. All I care is that someone out there somewhere can answer the question that I've asked. Now the really nice thing is that because I don't care, there can be more than one of these, and they can compete to answer the question for me. So when we're talking about scaling out again, then I can put a request on the bus, and in this case, we've got one queue, and these guys are all competing to handle messages, to handle requests off the end of that queue, which means we get a really nice inbuilt pull-based load balancing approach for free. There is no load balancer here. No load balancer whatsoever, it's just a pull-based queue. Who went to school in Brisbane? Like primary school? Yeah. Do you remember that game that they played in primary school where they put a whole bunch of like little beanbags in a basket in the middle of the children, and then they put teams of children at like either end of the tennis court, and you had to run into the basket and pick up just one ball and steal it back? Does anybody remember that game?
Beanbags, wooden things,
Beanbags. Okay, fine. Rocks, fossils, whatever. So that's pretty much your definition of a competing queue. And the whole idea is we have a queue of, in this case, beanbags or fossils or meat or whatever. In the basket in the middle, and everyone is running to and from the queue to compete to consume that queue. Whoever gets the most things at the end wins, but I don't care about that. So the nice thing is that if I have one team of students and they're running back and forward, then say like I've got one student that can just run forward, back and forward, and back, then I can only consume one item from that queue at a time. All I have to do to scale that out is add more teams of students. So more little consumers, more little primary school children running up, grabbing a little beanbag and running off again. If I have 50 of those, then I can empty that basket really, really fast. Scalability for free. There is no central distributing authority that sits there at that basket and throws beanbags at the students. It doesn't work that way. It's pull-based. Does that make sense? I almost feel bad about heckling this talk, but then
especially all the next few guys are in the room. We just compare them to throwing beanbags at students. Private students.
Yeah, I did say almost felt sorry. Right. Now, we'll have a look at multicast request response later, so you can do some really, really cool stuff with this, but it's probably a little bit outside the scope of this talk, so if we get a chance and you're interested, we'll come back to it, otherwise we'll leave it. And likewise, we'll leave that one as well. Yeah. Okay. So, we've talked a little bit about modeling for scale. We've talked about how by removing the knowledge of who we're talking to, it doesn't have to be a single entity that we're talking to anymore. It can be multiple instances of that entity. It can be multiple different types of competing entity as long as they do the same thing, provide the same service, answer the same question, whatever it is. Now we can have a bit of a look at a totally hypothetical example of how we might actually need to scale a particular business problem. So I should give you Gadget.
All right, this is my excuse to stop heckling and stop rambling. Yeah, all right, so this is kind of talked about a lot of this stuff in my consulting time a lot, and an analogy that seems to most people get is this one. So I want to talk about this very hypothetical company called Rainforest.com, which is the internet's largest vendor of books and DVDs and products of all manner. Sorry?
As opposed to big wheel.
Yeah, exactly. So, we're talking about a big online store, really, really ridiculously big online store. Now, you might have a little online store. You can go and get a whole bunch of off-the-shelf, open source, PHP, shopping carts. That's the schema from Magneto, which is kind of the most popular, probably, PHP kind of e-commerce solution. That's what that looks like. And compared to Rainforest.com, this is pretty simple, pretty small. But that's what its database again looks like, which looks like a barrel of fun, right? Now, if we tried to scale, if we tried to run Rainforest.com on top of Magneto, what do you think is going to happen?
Lifting a join would be a bit of a problem.
Yeah, there's a word, it's a four-letter word, starts with L, rhymes with clock. This thing's going to block. ridiculously. In fact, you're never going to get anywhere with anything, anytime, ever. Yeah? Makes sense? You know, you can't scale. You couldn't build rainforest.com on one relational database. It's just not going to happen. Yeah? I've been arguing with Daniel all day about relational databases. Surprisingly, the opposite of what I'm talking about now. But yeah, you try to build a really big e-commerce platform on top of that, you're not going to have a very, very good time. Does anyone want to argue with me at this point? Just want to put a checkpoint in the transaction log right here. We're all good so far.
You didn't dig up commerce servers.
Sorry?
You didn't dig up commerce servers.
Would you like me to?
Were you on the project that the Grays on?
No, not Grays. No, I have been on a project that removed Commerce Server, and I have a few grey hairs from it.
Yorkshire. This is Yorkshire.
Yeah, Commerce Server. That's a special platform.
Where did that ever go?
Sorry?
Why did that disappear?
Why? Yeah, so it was like, Microsoft bought it, and then went, and they sold it again, and then they bought it back, and then they sold it again, and has anyone used Commerce Server?
Long time ago.
Long time ago. Is anybody keen to again?
How do you like your XML?
How do you like your, what is it, generic COM exceptions? If you have a desire to play with Commerce Server, come and see me later and I'll tell you some fun stories. That sounds right, yeah. The funnest thing about the code base with Commerce Server that I remember was every step runs through a series of handlers. You basically go, look, we want to do this thing, and it runs through all these handlers, and the handlers say, hey, look, yes, I care about that, or I don't. And in this particular code base, by the time, it was a sort of rescue project we were involved in. I think by the time it got to near the end of the project, the developers were so panicked, just so desperate to get the thing to actually run. There was a method on a whole bunch of the handlers, which was a void, for the .NET developers in the room, which is most people. Public void manage that took a params object array, which is just saying, just give me some stuff and I will try to deal with it, which is pretty much the mental state of the developers at that point. It was just kind of, the management coming in and just going, just deal with it. They're like, okay, we'll try. Conway's Law. Who's heard of Conway's Law? Where the communication channels in the organisation is, replicated in the code base. This was a perfect example. By the beginning of it, they had this beautifully structured kind of domain-driven design stuff, and by the end of it, it was just manage his bag of stuff. We don't know what it is. You don't know what it is. It could be something. We don't know.
And then you go off and blame the infrastructure people for installing the MSI.
There's a long list of people to blame for that. Like I said, catch me later. Anyway, total tangent. No, I wouldn't build rainforest.com on Commerce Server. I know I'm in the Microsoft. There's actually people in this building that really don't like me because of that. You're the guy who took Commerce Server out. Yes, would you like to know why? Anyway, digression. Rainforest.com on that, not going to happen. Okay? So, in rainforest.com, we need to start looking at, something that, this week is called Microservices. Back when rainforest.com started to do it, they called it SOA. Today we call it Microservices. These ideas really aren't that new. The difference is, rather than this big system on top of a single big, all-knowing, all-encompassing relational database, we have a whole bunch of little services that kind of handle their own persistence, handle their own data store, and can communicate. And that's kind of the sort of the big differentiator. We've got these small services. Going back to relational databases quickly, they were great when disk space was really, really expensive. And you really could only afford to store a thing once. Once only. We don't want duplication of this. The relational model works really, really, really well for that, for those sorts of systems. But it doesn't work really, really well at scale. Yeah. So now we've got all these different data stores. We've got document stores, and we've got. You're just waiting, I can tell. We have document stores. We have key value stores. We've got. Yeah, there's a time and a place for everything, except client server. You know, there are some things that a document store is great for. There are things that a graph store is great for. There are things that a key value store is great for. We don't need to try to shoehorn everything into a relational database. Yeah, and that's kind of the big thing now. We can afford to spin up an Azure instance with this. You know, we don't have maybe you do, have a 6-month waiting list to put in a request to get a new. See, I'm going to give back. You give to me, I give back.
Documents don't know about this thing called ITIL and Prince 2.
Oh, we do. We just don't understand it.
Yeah, that's
They tend to not.
Okay, all right. So great. Okay, great example. Would rainforest.com be the #1 e-commerce retailer in the world with ITIL? No, they wouldn't. You know, look at ITIL shops and how successful they are in delivering software. Queensland Health. They are probably fully ITIL. We've got someone to sue. It's okay. We're ITIL. Let's not go there because ITIL keeps a lot of people employed. Not a great way to get stuff done. Anyway, and I think we had this argument last time. And I went, you know, I went a repeatable solution that's automated, that doesn't involve idiots touching it, is much better than a Word document. Anyway, if you take the attention. Anyway, so we've got these small things. They've got different persistent stores. It doesn't really matter. It can be in whatever format because we've got this underlying way that these things can all talk to each other and basically keep in sync. So, make sense? Anyone want to argue with me some more? So, microservices. So, small, discrete services that handle, you know, a small set of stuff and store in the way they want. You know, we could have one thing here when we're talking about scaling. You know, we might have one service that does something. We might, you know, spin a whole bunch of them up using those messaging patterns we talked about before.
Are these hexagons for a reason? Is that Alistair programs?
No,
They're always hexagons.
Squares were boring.
That's what microservices are always actually.
So, who's read this? Who's actually read it all?
Who stayed awake?
It's really hard to read. It is really hard to read. And the thing is, and you know, I've been having this discussion with Daniel there today too. He was talking to me about no, real domain-driven design. And I went, you mean you sit there with a domain expert, you know, paired for 9 months and well, no, not that real. So everyone has their own version of the domain-driven design religion. Starting with, hey, look, we've got something called repository in our code base. We're totally DDD. Who's worked with that guy? You all know, no one in a minute. Who is that guy? Who stayed awake through to chapter 14 when he starts talking about bounded context? No, 2 people, 3 people. So one of the great things about domain-driven design, because I mean, ideally, this is a book which is largely about just good OO design principles. You know, with a little bit of, hey, this is what works for us on these projects. I think that. If anyone's heard Eric Evans, I mean, really smart guy. If anyone's heard him speak will realise what the book's hard work. It's just like, he just talks like this. That explains a lot. Really smart guy. And there's a whole bunch of stuff that worked for him, and basically, it's like reading the Gang of Four Patterns book, which is another book that everyone owns and no one's actually finished. It's a shared language of, you know, being able to talk about these patterns and concepts and stuff like that. Right near the end of the book, he starts talking about bounded context, and he's actually said if he had his time over, he'd put that chapter at the beginning, because he talks about the idea that you've got a domain, but you actually have, in any big business, you have lots of domains. Yeah, and the domain looks different depending on the context that you're looking at. Does that make sense? Sort of, yeah.
Just on that really briefly, who's heard of the term ubiquitous language? How across an entire organisation, how ubiquitous is it? When we say I have an order, for instance, Does that mean the same thing to everybody in the organisation? Same thing across business units? Maybe. Does it mean the same thing to two people who do the same job on alternating days?
Sometimes. Yeah.
So there's your clue.
Yeah, it's within the bounded context. Dan North has a great example. You know, you're sitting at your desk and you're looking at a photo of Fiji and you're like, yep, I'm going on holiday, and you put in your request to go on holiday. To you, your holiday is about sitting on a beach in Fiji with a cocktail in your hand. Yep. To the HR department, it's about a leave request that they have to approve. To a travel agent, it's about some flights and hotel. So you're all talking about the same thing, but everybody has a different context and a different set of data that they want. So trying to model you going on holiday as a relational database isn't really going to work. They're very, very different things. Yeah? With me so far? I'm jumping on that a little bit, but it'll sort of come back together. So let's think about bounded context in the context of rainforest.com. Now, if we had a bookshop that was, you know, this big book warehouse where we took mail order, you know, talking old school, mail order catalogues, you know, ordering some books, we might have a shop front as well. And in this fictional bookshop, you might actually walk into the store and say, hey, I want these books, and they go, yeah, cool, we'll ship them to you. Which is sort of a real world analogy to, you know, an e-commerce site. So in that, you know, we've got a bunch of workloads. You want to come in and say, hey, look, I want these books. Yeah. You want to pay for those books. Yeah, however that order comes in and the payment comes in. Somebody's got to get the books off the shelf in the warehouse and maybe post them to you, put them in a bag and send them. You might get an email or a fax or a letter or something saying, look, here's your invoice for these books. You know, you might get an email or a fax or a carrier pigeon or a telex when, you know, the order's shipped. Somebody wants to keep a record of all the books sold so they can kind of look at some financial information for their business. Something made up, but yeah, these are kind of real world things. Some other real world things that happen is stock level might get low, stock can run out, your check might bounce. Make sense? Yeah. Now, building something like this on top of Magneto and trying to scale it is going to be really, 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 really hard because of database logic. So, if we were to think about, you know, this real world business where we kind of walk in, and we think about that in terms of, you know, this very transactional system where everything is locked. It could be you walk into the shop and you go, do you have this book? There's a line of people behind you that also want to buy some books. You walk and say, do you have this book? And the owner of the shop goes, let me check.
Barry, do we have a copy of Domain Driven Design?
Yes, we have that. Great, I'll have 2 copies. Ah, hang on. You know, meanwhile, there's a line going out the door and eventually they go away. Make sense? That's my rough analogy for database locking at scale. Yeah? Where we've got this very synchronous transactional thing where nothing can happen. You're just like, hang on, I can't serve you because you might want a copy of domain-driven design. And I can't let you know if you can have one until I've gone out the back of the warehouse to give, you know, Fred his 2 copies. Make sense? So, you know, a real business doesn't do that because you'd never be able to scale it beyond one person. You know, and it just wouldn't work. So, you know, instead we might say, hey, look, do you want this book? And this is a very rough real world analogy for an e-commerce site. Do you have this book? Yeah, we've got a bunch of those. Take your money, you know, take your check, we'll send them to you. Yeah, now we've got a warehousing system where basically we kind of write down some packing slips. So, you know, take some packing slips out to the warehouse to say, hey, look, pack these, go find these books on the shelves, put them in a box, send them to that guy. Yeah? Make sense? Now, I'm losing people, I can tell. Morgan's very skeptical.
Yes.
Does that make sense? So, you know, I've taken the order, and, you know, and as the person at the front counter taking the order, I care about, you know, I care about the customer's name. Sorry? Everyone's just going to sleep. You know, so I've got, you know, the person at the front counter, you know, might care about your name, you know, they might take your money, they might do a whole bunch of things, kind of spend some time greeting you. Barry in the warehouse doesn't care about that. We just fix packing slips off the off the in tray and goes and picks them up and sends them. Yep, that's messaging. You know, so while front counter, part of my domain, part of my context is, you know, customer name and all of this stuff, what the warehouse guy just cares about is who's it going to, what's the address, what books do they want. You know, they don't care about all the rest of that stuff. So we basically write down on the packing slip, do this stuff, and that's what a message looks like. So we've got, you know, a shop front system, we've got a logistics system, and we just pass a message between them. Now the other thing that you might have in Magneto is, hey look, I want to buy 2 of those things, and it locks the database to check the stock levels to see if there are 2 of those things to give you. Rainforest.com can't do that, but if you have a shop there, you might see, hey look, stock levels are low, we've got less than 10 copies of this. You know, and that's telling you as a customer, by the time you order this, there might be a backorder situation, or it might also tell you, hey, if you're pondering buying this, do it now because there's not too many of these left. Yeah, has anyone seen that? If they've been to something like rainforest.com and stock levels low? So what might happen there is, the guy in the warehouse is packing and shipping books, and he kind of comes up and goes, hey Bill, we're running out of copies of 50 Shades of Grey. Noted. So then the next time comes in, someone comes in, wants their books, like, oh look, we're running pretty low on that, but we should be able to sort you out. Yeah. Meanwhile, somebody else heard that and goes, yep, cool, I'll reorder that. So you got a couple of parties involved in that little conversation, which is, hey look, we're running low, and at the front of the shop you kind of hear that and go, yes, I can let my customers know we're running low. But then your warehouse manager that's responsible for ordering stuff, he hears that as well and goes, yep, okay, I better order some more of those things. Does that make sense? So we've kind of got this, a few different of these messaging patterns in there. We've got our command, which is, hey, look, ship this order. We put the details on a packing slip. That's our command. Yeah. And if our warehouse gets really, really busy, we can hire some more casuals. Those casuals can be really, really dumb because all they have to do is follow the instructions on the packing sheet. So they don't need to know about the entire business of running a bookshop. They just need to know, go find these books, put them in a box, write the address, send it. And we can scale that out really well because they're just taking messages off a pile. But the person, that's in charge of reordering stock, they can hear that same message, hey look, we're running low, and they can order some more stock. So that's that kind of pub sub. Here's an event, we're running low, different people can hear that and react to that in different ways. Make sense? Yeah. So this is kind of example of, if you think about, you look at these messaging patterns and microservices and go, well, what does it all mean? You think about, one of these big, complicated business models, and you think about what would happen if we took away this kind of big monolithic software model of that and actually put people in those roles, and each with their own context, and that's kind of what a microservice looks like. So you've got somebody in charge of logistics, somebody in charge of taking the order, somebody in charge of ordering more. You might also hear when we say, hey look, we just sold, this many things, yes, the warehouse has to respond to that and send them. You might also have the person doing the books kind of goes, oh look, we sold, this many more things. Here's our, a daily total. So you've got the personal finance system kind of listening to that information as well and recording it. Make sense? Yeah? Again, it helps with problems. Stock levels get low, we've talked about that one. Hey look, we're running out of this, we can do something with that. Stock can run out, so you might, look, we've put an order in, it's like, oh, that's the last copy of that book, it's gone now. Look, we'll send these 4, and then keep a record, look, have a note here saying, hey look, when some more copies of this book comes in, we need to send one to so-and-so, yeah? Whereas, I bet if you did that in Magneto, you'd probably just get this big horrible deadlock and say, oh, couldn't complete your order, sorry, Certainly that happened, something similar happened in the commerce server experience.
Just generally on the stock running out thing as well, from a context boundary perspective, what's the warehouse's job? Okay, so they fulfill an order. When they go to the shelf and they say, when they go to the actual stacks, they go, oh, we run out of DDD because it's really, really popular. What's the jumping off point of their responsibility?
Tell someone to order more.
We're out. That's it. All they have to do is announce that they've run out. Now, we looked at what we would do in the event that we had taken someone's money for an order and then we couldn't fulfill that order. But it's not the warehouse's job to decide what happens next. The warehouse just says, I can't fulfill that because we've run out of stock, not my problem anymore. Now, we've actually got a couple of options there, and we'll come to compensatory actions later, but we've got a couple of options there. One, we can put it on back order. Two, we can credit the customer and say, look, we're really sorry, we're actually not going to bother ordering that book anymore because it's really boring and we're the only person in 50 years who wanted one. And just so happened that we sold 2 copies in one day and yours was the second. Sorry. So we might give you a refund and maybe give you a gift voucher or something else to say sorry, but we can make that decision based on just the event that the warehouse has published for us. The warehouse doesn't have to get involved in the decision. All the warehouse has to do is say, we don't have any more order coming on.
And at the end of the day, the manager can walk through, oh, we couldn't fulfill this order. Oh, look, no, I will give him credit. He can make that decision as the manager of the store. Yeah.
I'll come and put a request response line in there just to step into
Give me a sec, I will. Yeah, payments can fail as well. I don't know if anybody's, placed an order on something, that their credit card that was on record just expired or whatever, and you get an email saying, hey, look, it might be, a few hours later, we tried to charge your card for this, but, it didn't work. Here are some options to rectify. You can come in, change your payment details, cancel the order, whatever. Because we didn't do the whole thing in one giant transaction and go, oh, we tried to hit the payment gateway as part of that database transaction. It didn't work, so we rolled the whole thing back and showed you an error message. Again, connoisseur. Does that make sense? You kind of, you couldn't lock the world while hitting a payment gateway at the end of an HTTP request. Locking while that would happen, you're just not going to be able to scale very well at all. It's better to take the order, say, yes, we've got your order, and then come back and say, yes, it was successful, yes, we've shipped it, or no, look, there was a problem, come back here and give us some more information so we can continue this process. Yeah? With me so far? Is my analogy kind of holding water for everyone? Yeah?
Are you going to mention, I guess, where the data is actually stored? Like where in that system you would store that data? Like if you've got the stock levels for an item, are you saying that would be something that another microservice would deal with you and you would sort of announce that there's no stock? You've got stuff?
What is the definitive source of truth around stock levels in the warehouse?
Physical stock.
Yeah, okay. Does anybody else keep any kind of mental note about we may have certain levels of stock in the warehouse?
The front end system possibly?
Yes,
why do companies do a stock take sale? Because they trust their front end system. You've got staff knocking off books out of the warehouse, you've got, so it's, look, we've ordered this much, we should have about this much, but really we know we've run out when we've run out. We can say, hey, look, we're running low on this, we need to order some more. But yeah, the reason that people do stock take sales is their systems get out of, you might have some damaged stock, you might have, typically you've got, your warehouse staff that you're treating terribly that go, right, I'm going to get these dudes. So yes, we do have warehouse systems that say, look, this is how much we should have. So in this instance, it's not the warehouse staff that are picking and packing orders. It's not their job to know exactly how much, to keep track of what's coming in, what's coming out. Their job is just packing orders. So they actually don't need to store any data. They're just dumb workers. It's like, here's this, pick it, pack it, tell me when you're done. You might have another, service that sits there and goes, that kind of knows what's been ordered, knows what's arrived, knows what's been sold, and should say, yep, we should have roughly this many, which will, give us an indication of, how fast we're selling it, when we need to reorder it, that kind of stuff. Do some predictive analysis on that. But really, if you think you got 50 copies in and you think you've sold 40, but your staff have knocked off 6, your system really isn't going to know that because the real world isn't perfect. And I think that's the thing when you try to build this big transactional system. It tries to apply the relational database model of this referential integrity, and you try to apply that to the real world. It falls apart really, really, really quickly. And that's where sort of having these small services that kind of keep track of their own data store, but can have these actions that compensate for things is a way to build systems that are simpler because they're not trying to bring in every business rule under the sun for every action that happens.
So if, I guess, for example, if you had the back-end warehouse, if a new product came in you've just got, then there could be a command that says new product, and the front-end system could pick that up and go, hey, they can store the title and the picture or something on it.
We think we just received 50 more of these, stock levels should be great. Yeah.
Just on that context boundary point for a second though. So our warehouse is the definitive source of truth for our actual stock on hand. What's the definitive source of truth for how much money we have?
Finance system?
Finance system, I'd actually say the bank. my banking, I would love to say, hey dear bank, my finance system says that I am a trillionaire. I'll have to pitch you. But I'm so totally not. We've already actually got all of these context boundaries, and the fact that we tried to shoehorn this into one consistent transactional relational model, we've already accepted failure on that. As soon as we have any form of reconciliation, location validation, or anything along those lines, we've already accepted failure. We've already accepted that we don't ever have one true model of the universe other than the universe. So we may as well go and ask bits of the universe that actually have a definitive answer when we need to. We don't always need a definitive answer though, which comes back to some of the state information that we can store. We don't need to know precisely how many copies of a particular book. We know that we're probably running a bit low. We know that we think we've got enough. We know roughly to within a certain number of how many copies our staff are knocking off every week. But unless we actually have a specific reason to know exactly how many we have, in other words, go into a stock tank and count the things.
And hope that nobody steals it during the stock tank.
1, 2, 3, 4, hang on a minute. Yeah. But we generally don't care. We'll actually accept a stale answer. More than, how much money has it done answer? But if you know how much money has your bank account got right now, well, you know the last time you saw a balance, and you probably know whether you've got like an island's worth of cash or a caravan or a Snickers bar's worth of cash. But you kind of don't really care about down to the cent exactly how much you have. You care approximately, you know where I guess your boundaries are, where you actually really want to go back and check. But we are happy with stale data. I guess just keep that in mind when we're talking about where persistence is. Persistence isn't the be-all and end-all of modeling pretty much. It's just keep that in mind.
What about when you do care, like selling, I don't know, plane tickets or concert tickets where you can't oversell?
That's another talk, and I'm sure you've seen it.
There's a YouTube video on that from some bloke. You should watch it.
It's been unfair you keep talking about referential integrity, because it's really the entity counts where that is, whether it's in a relational table or you guys just look over into the framework and link it away anyhow. But yeah, so it's really, and there's where it counts. It depends horses on for courses, because this day and age you hear this term BI, which when I was growing up meant something else. But so things like.
Are you letting me make my BI curious joke again?
things like theft and intelligence and big periods like florist at Mother's Day. And
so yes, and I've got a picture on that. Is yes, we do care about that. We do care about data warehousing. What we're not doing though is having one database where we're running all of our BI and all of our reporting and all of our predictive analysis stuff. We're not trying to add transactions to that in real time and make our customers wait while we're doing it.
Yeah,
and that's the difference. So yes, and the thing is that in this world it works really well. And I think they have a picture. Is if we've got these sales coming through and all of these events floating around, we can actually pull them as messages off and load them straight into our data warehouse because except it's faster. And cheaper. So we can have we can service our customers really, really quickly. We can send emails in the background. We can do payments in the background. We can send this off to our warehouse system in the background, and we can have something else listening that has a very, very different model, because if we've got a good BI system and a good data warehouse, it's going to have a very, very different storage structure and a very, very different schema to what we might have to really efficiently serve customer-facing requests. So again, that's a bounded context. So we can say, hey, look, we've got this information came in that, look, we ordered these books and this many came and we lost this many. And we've got this information floating around the system that says, look, we've sold 17 of these things and we seem to have a spike of selling this book on a Friday afternoon. We can pull all that into our data warehouse and, within the context of that, store it in a way that it makes sense and, query that ridiculously while not affecting that. So a microservice architecture ties in really, really nicely with BI. The difference is we're not running nightly SSIS packages on the world to make it happen. Because we're a lot more loosely coupled than that, so we're not having to manage SSIS packages. So because we've agreed, our messages are a data structure which is basically an agreed contract. So we say, look, I'm going to publish a message and it looks like this. You can rely on that. Internally, how I store stuff can change because we've agreed on a contract for how we're going to pass the messages around. What that means is, and I've seen people be bitten by this really, really hard, when your data warehouse relies on an SSIS packages that ties into that and that and that and that and that, it stops these teams from being able to make the changes they need because the BI team get really miserable and upset and have feelings when you change when you change some minor part of your schema and all their SSIS packages break. And nobody knows that for 2 weeks, and all of a sudden this data looks wrong, and then everyone runs around with their head cut off trying to figure out why the data looks wrong, to figure out that, oh, the SSIS packages haven't been running for...
If you ran vital shots, that
Sorry?
wouldn't happen.
How much are you willing to bet on that?
I'm going to take the bait on that. I'm going to throw a question.
No, I want to know. Put a number on that.
Change release management.
No. Oh, really?
Change production.
Put a number on that. What are you prepared to bet that in an ITIL shop that doesn't happen? Because I can take you to meet some financial institutions tomorrow.
Well, it's the same with Agile. So what is really Agile? You'll hear people say, we run Agile, but it's sort of fragile.
That means they stand up in the morning?
Yeah, well, they do Agile.
They have ceremonies and they wear funny hats.
There's idle, and yes, it is bureaucratic, that is.
So just on that though.
Again, what is the source of truth? What's there or what the Word document says?
What the Word document says.
Well, if you've got to, listen, if you've got to rebuild from scratch because you're not happy with the developers and you need something that's set instead of the comments in the source code that's in the way in Octopus somewhere hosted in a cloud that you no longer have access to.
Would you bet that on a set of Word documents?
Probably a few, yeah. I have a couple of schema diagrams pulled out from Management Studio and a few other things.
I will take a Git history thing all day. But on that though, that's actually a valid point though. Change control. Right? Now everyone, well most people, implement change control. Think about this though. What is the actual purpose of a change review board or whatever you want to call it? But why do we actually have change control?
Why do we have ITIL?
Well, it's
thought it up.
No, what's it about? It's about repeatable processes, right?
It's about fundamentally flagging with other players in your ecosystem to say, hey, I'm going to do a thing that might impact you. At the fundamental level, that's what change control is for. Okay? It's not to dot I's and cross T's and make sure that nobody gets fired when something goes wrong. Things go wrong, we fix that, that's fine. Things go wrong, whatever governance methodology we have, that's fine. You just have to have some sort of responsible rollback or mitigation process. That's not the point of this. But the point of change control is to say to everyone, hey, I'm going to change this part of the universe and I think it might impact somebody else, so here's your chance to pipe up and say, yep, that might be me, we should talk. Right? Now, if we have, for instance, an SSIS package that reaches its tentacles in here, pulls stuff out and reaches tentacles into here and into here and all the rest of it, then all of this needs to be subject to change control. We all of a sudden, we've moved the locking from our software to our governance. So we still have an exclusive universe level lock, just that it locks on process and software rollouts rather than actual transactions. If we can, however, say, look, I can change anything I want in here, and all I have to guarantee is that I will respond in exactly the same manner as I did a microsecond ago to the same shape of query. I will give you the same response, I will honour the same service contract, and of course, because we're responsible, we have regression tests against this that will automatically hammer against it every so often. We can say, look, one, if we change this, we'll know about it in a big hurry. But two, we can change anything we want underneath here, and we don't actually have to go and tell the universe, because the universe not only doesn't care, but actively doesn't want to know. So think about it, when you're looking at change control and governance and all the rest of it, what you're really doing is you're saying to people, hey, I'm going to do a thing that might break you, here's your chance to have an opinion. If I'm really, really confident that I'm just not going to break anyone because externally visible changes aren't going to happen, then it doesn't need to be subject to that form of change control. Does that make sense?
That makes sense in an evolutionary change, but in a revolutionary change, it doesn't work.
Let's come back to that. Because you're right.
You
need to get that.
But revolutionary changes usually don't work anyway. Who's done a ground-up rebuild of a system, like-for-like system that worked really, really perfectly?
All I know is that the executives control the environment, not the developers, and whilst you may be theoretically right from a developer perspective, the executives will do what they need to do, and so we as IT professionals need to respond. And so you can complain all you like, but we must be able to respond to executive issues.
Absolutely, but that's kind of what agility is about. It's being able to respond.
I get it, but suggesting that no external facing changes, as long as we agree that doesn't
no.
So let's
There will be some.
I'm saying,
you can make incremental changes in here. But the other thing is you can say, right, from tomorrow, we're going to use a new logistics system, or we're going to start. Yeah.
Oh no, we're changing business process.
Yeah, look, absolutely, and that's great too. Okay,
It's
so
a revolutionary change. We're
great
going
example.
into a new business.
And I can talk about this because I've seen it done. Okay, with this sort of architecture, and it was look, we've got this old legacy system. The people that built that want to retire.
there's only one left.
There's one guy left and he wants to go. He's bought his camper van, he's gone. We need to rebuild this thing. Except they had about 5 years notice. This is a real story. They had about 5 years notice, so they went, right, software development hard, we'll go buy something and customize it. Great fallacies in software development, right? And it was this big off-the-shelf product, and it's okay because we're not doing software development, we're just doing configuration. Fallacy number 2 in software development. Because configuration is all of the work of software development without the tools. So they start configuring this big system, and the thing is that yes, business processes do change, legislations change, acquisitions, internal process changes, and every time one of those changes happened, goalposts got moved. Work over here would stop. It's like, look, we just need to do this. This isn't live yet. We'll do it over here. So all of a sudden, investing more in your old 20-year-old legacy system than the new shiny. And 5 years of this and nothing got done. The goalposts just kept moving and moving and moving and moving and moving. So I was involved in a project that basically, look, you need to help us just get moving on this. And actually went, well, look, today you just need this feature. So let's just build that feature. Now, it needs to have a storage of some data that looks like that, and it needs to know when this happened, and it needs to know when that happened, and it needs to tell everybody when that happened. Put a message bus in there, build that feature, push those events out to the other system, and seriously, within a couple of weeks, there's your new feature. And again and again and again, repeated this to the point where it's actually, look, this kind of off-the-shelf thing that we've been trying to configure for 5 years that now everybody is sick of the sight of and hate, we can actually just turn it off because we've been able to deliver these features. And new business just got acquired, we've got these new processes. No problem, because the business events generally don't change all that much. It's just how we react to them. So an event of, look, we just sold something, and it costs this much. There's not too many things that can change about that. If you're selling something, you're going to sell something. How you react to it, so you could have one service that reacts to it in the old way, and then quickly spin up a new service that reacts to it in the new way, run them side by side for a while, and then go, we're not doing that business process anymore, turn it off. And it's a way of incrementally taking on an evolutionary business change, step by step, and replacing a system, piece by piece. And I've seen it work, where it's, look, a major legislation just changed, or, we just acquired this massive new business with all these new processes, and we go, look, no problem. You look at a certain Queensland government department's payroll system, where it's like, no, the contract says that on this date this thing's going to work. Cool, no problem. Turn that one off, turn that one on. Guess what? No one got paid. Whereas if you kind of were able to go, look, here's this event, these people work these shifts, pull them into both systems, and go, yep, we're happy with this one now. Let's start using that. So it actually does work for really significant process changes because. You might have extra events, but by and large, the events are quite simple. We sold a thing, had this name, had this code, and sold this much money to that person. Everybody has a different view on that, and you might have to react to that very, very differently, but largely the events don't stay the same. So it can and it does work.
Just because you said before you have a contract at the message.
Yeah.
It's just like front of the web application, it's capturing this, it's creating a message, you give a format, and tune. A change occurs.
Yep.
What about having contractually obligated parts of the message?
Message versioning?
So not so much versioning, but just adding, here's extra bits that one system needs, but no one else knows about, so just ignore from this point onwards.
Yeah, so message versioning is hard. It's a hard problem to solve, and it can be. We're just going to add some extra bits of data to this, and you can ignore it over here, or use it over there. If they're really different, then sometimes for a while a system might put out 2 copies of a message, in different formats. Like if something semantically does change, you might say, look, for these systems they want it in this. They're expecting to look like this in a new system. So you might for a while publish 2, and then slowly, deprecate some of those other systems. Or it could be, look, we're just going to stick some extra data in this. How you communicate that internally, there's different ways depending on what platform you're building to do package management, to kind of advertise, hey, look, there's a new version of this stuff, start to transition to it. But there's nothing wrong with just putting really extra features on a class or something like that, because they don't have a lot of behaviour. It's just, with this bit of metadata, we can send you a few capabilities, essentially.
We've solved this problem a number of times over. The most successful approach seems to be we just version the entire message contract. So what I was saying earlier about over here, I promise that I will not respond differently to the way I did in Microservices to go to the same message, but that might be version 4 of that particular message, and I may respond differently to version 5 of that message. When we get to version 300 or whatever, the messages themselves, they tend not to change very much. What tends to spook people is the thought that if they change at all, they're in trouble. Hang on, we've got there's one more mandatory field and it just absolutely has to exist. Add it. And if that means that you add it at the producer only first, then you can usually just start dropping the message types onto the wire. When you put events on a wire, the producer of that event can generally publish just the latest version. And what you can do then is you can have a bridging microservice. You can do it in the same application, the same service. You don't even have to publish 3 versions of the event. What you can do is you can say, well, I'm just going to publish the latest one, and then we'll have some sort of intermediary that just subscribes to the latest and publishes the 2 before that. And then when we go and look at the subscription counts, no one's actually subscribing to version 2 of that event anymore. I guess we can just switch that off on the broker. And then, hey, no one's subscribing to version 3 of that event anymore either. So we just switch that off. So we can completely, drastically, 100% change a message contract. We can change the data types, we can change the names, we can change everything we want about the thing. The only rule is that all of the previous ones that are still in use need to be honored in the same way. But what that allows us to do is roll out a couple of changes here, roll out a couple of changes there, changes wherever they end up happening, and then we can just go and do some inspection on our system and say, well, these particular message types. Now that we've rolled everything out piecemeal, so low risk, progressive over a week, a month, a year, whatever it takes, but we've rolled out all of these changes. Now we aren't using those old message contracts anymore. We aren't using that old system anymore. We can switch off the old system, we can decommission those message types. And in a lot of cases, we actually have automated tests around asserting that, for instance, if you handle a particular version of the message, then you have to handle all the subsequent versions as well. And then that makes it really easy to just get prompted, hey, by the way, when you're updating this thing, there's a new version of that message, you should probably deal with that.
So I'm just saying, if an event happens, you pump out both versions?
I would generally, it depends on how heavy rated it is.
You can, or you can pump
Just pump
out
out.
the new one and then have a relay for some of your legacy systems, or if it was a minor change, you can pump out the new version, but the old systems can read it, either because they can read both versions, or the old ones are compatible enough that they can read it. There's a few different strategies. It depends on what the message looks like and how drastic that change is.
Should Postel's law would come into effect?
Yeah.
Yes
yeah,
and
exactly.
no.
You know.
Yes and no. Don't
Except when it
forget,
doesn't.
Postel's law is responsible for RFC 822, which is responsible for email address validation being basically it has an @ sign in the middle. So being lenient in what you accept is kind of good and also kind of really evil. You should definitely be very strict in what you send. You want to be a little bit prickly about making stuff up. If someone, so if we have an optional field, then yeah, sure, it's allowed to be optional. But if it's a mandatory field, don't have a guess. Don't just say, oh, well, they didn't specify a from address in the email, so I'm just going to take it as whatever they said hello as. I'm just going to dump stuff. Okay? And, in the early days, a good third of the world's spam problems went away. So be a little bit more stringent in what you accept. Basically, if you are confident that you can handle something correctly without having to guess, do it. If not, bounce it. And there are ways to bounce it where you can make those failures very, very visible and easy to deal with.
That's the other thing with this. You end up with instrumentation and monitoring in there, so you can say, hey, look, I failed to handle this message. Raise an event to say, hey, look, this thing failed, and you've got no sort of real-time analysis to go, why did that fail? If you're putting, so yes, to an extent, Postel's law does, but you don't want to fish with trap either. Yeah, we could be a little bit more specific because it's generally an internal environment rather than or I use it. Sorry, that was another question.
What did Queensland Health ever do to you?
It wasn't your fault anyway.
That's why IBM is.
I'm going to let that one go.
Well, Sweden wasn't the IT guys.
So to be fair, they did have people resigning in protest saying if the system goes live, I quit. They get some credit for that. But they were, a quote from Damien here, they were the shape and the structure of an organisation that allowed that debacle to occur.
It wasn't the IT guys.
No. It was the organisation as a whole. Let's say it was not defined as that.
So just on your arguments about SSIS here,
yes.
Just some thoughts. I mean, I get that if you're completely message-based and everything is there, that's awesome. But I would imagine there's going to be some cases, or there are some cases, where you're going to want data in your data warehouse that's not necessarily data that is being used to communicate between systems. If that makes any sense.
Yep.
Like all of your customer data, for instance, not necessarily the customer goes through your messaging. So there's still a place for SSIS in that.
Maybe to bootstrap a new system, but a significant business event is we just got a new customer.
What about insignificant business events that you still want in your warehouse?
You'd still publish those.
You'd still publish them, though. So
publication with no subscribers, or even with subscribers, but as a general rule, if a thing happens, announce that thing. If an event occurs that changes the state of your universe in whatever way you're modeling it, but if the model of your universe changes, you should announce that. And by and large, you may have no subscribers, but one day you'll have them. And the nice thing is that the system that's producing those events doesn't know or care. As far as it's concerned, if you have a general rule that when I change the state of something that I'm responsible for, I announce that, then one day someone can pick that up and run with it.
An example of that, I've seen a system where there was a sort of e-commerce shopfront database, and there was some point-of-sale databases, and there was a third party that was involved in, it was essentially a CRM, and there were kind of big bulk loads from that to a data warehouse. And when the question was, do you want to get an email from me or not? Kind of customer opt-out stuff. If you had said yes in here, no when you walked into the store,
which order do you run your packages in?
Yeah, and then, or actually maybe you said, yes on here, and then you got an email from us and you said, no, I unsubscribe, and then you went into a store and you went, no, actually, I do want that email, and it was all on the same day, and then at the end of the day, I do a big SSIS merge and go, who wins?
Don't you have that same problem with messaging anymore?
No, because messaging has timestamp. So you can say,
Just can't
this
go
happened,
through.
then this happened, then this happened.
So does your transaction log, but
I understand. I get it. It's an ideal world scenario, and if you control the universe, you can get a perfect scenario.
But no, but look, yeah, I mean, there's no silver bullet to anything, right? But if you had, if you controlled the system and you have these events come through, we got a new customer, they opted into this, but they opted out to that, and then they changed their preferences to this, and you can kind of pull those events in and load them in, then you're going to have a current answer, which is going to be more accurate than, trying to do a bunch of snapshots and figure out who wins.
I don't want to be rather short.
Each one of those servers now, rainforest scenario, is a copy of a massive catalogue.
It's not a copy of a massive catalogue, it's a storage of the information that's relevant to them. So you have a lot of, you potentially have a lot of duplicate data and redundant data. But so if I had a relational database and I want to say, show me all of the books in this category in a relational database, we can all imagine what that looks like. Probably got a category table, got a parent categories and child categories, and then products that can live in multiple categories. You kind of do a bunch of joins to figure out what products should you look at for this category. Now, what I could do if I had a kind of catalog management system off here that published, hey, look, we've changed something about the structure of the catalog, I could store, in a key value store for this category, here are the products. So when a customer comes here under load and says, show me the products in this category, I'm not doing this 11 table join, I'm just going, oh, you want those books? There you go, bang. So yes, the data is duplicated across systems.
I've got thousands of these web services on the front end.
Yep.
They're all containing duplicates of the same data, or parts thereof.
Yep.
I'm going to update all of my catalogs every day and keep all my prices up to date. My messaging on.
You can do. I mean, and this is, so the companies that have had to scale really, really big, that have kind of really done the work in pioneering, the Amazons and the Netflix and the eBays and stuff like that. That's what happens. Like this event happened and they populate that around the world, and every system that cares about that can make its own updates in the way that it does. And generally the storage is optimized for reads because it's optimized for the use that it's needed by it. In a lot of cases that's reads. So you look at bestsellers on Amazon, you might have an algorithm that calculates that every 10 minutes. Hey, bestsellers are blah, and it can store that. RAM is a lot cheaper than it was, when the relational database was invented, and disk space is a lot cheaper than it was. So yes, if you need to scale out really, really big, yeah, absolutely. But you can take those same lessons and apply them to smaller systems because they kind of give you that decoupling and there's a bunch of other benefits as well.
Don't forget, people tend to shy away from replication in any form of a lot of data, and it's not unreasonable. So let's actually do some back of the envelope math here. Let's say how many books are there?
Replication, shy away from big replication. What's big data?
Well, big data is something that I can't solve for you at Officeworks at lunchtime. If I can go to Officeworks and say, I will have all of your drives, please. I'll have a palette with 2 terabyte disks, please. If I can store your stuff on what I can buy at lunchtime, it ain't big data. Let's actually think about that. So let's do some back of the envelope calculations. Let's assume that how many books are there in the world, like ever published? Pick a number. A billion, 6, a billion. Okay, a billion. Now so at 1 byte per book, okay, how much storage is that? How many bytes is a billion bytes? It's a big one. Okay. How many bytes are we actually going to be talking about to store metadata about a book? Is that 100? 100 gig. Can you buy a 100 gigabyte drive? Can you actually buy? Seriously, can you go to Officeworks and buy something that small? No, but for $50 I can buy something that'll store 10 of that. So when you start thinking about the actual order of magnitude of a lot of this stuff, then it really kind of doesn't matter anymore. It's like literally here is $5, that's how much storage it's going to cost you. Now, not only that, but people tend to freak out about what they view as large data sets, because let's assume that we've got a 100 gigabyte SQL database and we want to do select star from book where catalog ID is, so where, you know, category ID equals something. So we've got 1 billion records and we're doing an absolute best index scan of 1 billion records, and that's not going to happen. If, however...
Yeah. How much RAM did those Azure instances have that you were talking about?
128
gig.
If, however, we say, well, you know what, disk space is kind of cheap, but we've got 10 times the amount of storage that we need for our entire freaking catalog because we spent $50 at Officeworks, we can then go and pre-populate a whole bunch of stuff. So we can have any form of, you know, sharding per category, sharding per popularity, sharding per who knows what, and we can project this out. And we do that as a write once when the event comes in. So we write one thing, we write a gazillion indexes on it, we heavily optimize it for reading, and then what we tend to find is, actually, the reason that we needed 50 instances of a SQL server is because we were doing the select star from book where. And where we had 50 SQL instances that were all escalating to, like, you know, row level, page level, table level locks, now we're just doing the select top 50 from some table, or just pulling it straight out of memory or whatever, and we actually find that we can start to handle not tens, but tens of thousands of requests per second, which means that we can actually scale down our instance count. We're not doing inefficient stuff anymore. We're actually optimizing for our common case, which is read lots of stuff really fast and pre-calculate the answer to that question. Now, this is getting kind of off topic, but what we're really, if you want the topic to Google, what we're really looking for is called a read model or a projection. But that's what we're actually doing here. If we project out into a read model that's optimized for the specific type of question that we're going to ask it, then it's a whole lot easier to answer that question. So if we did, for instance, select top 10 from book where, you know, left join popularity or sales or whatever to try to get the 10 most popular books, we are in a world of pain.
So we could rename this talk, How to Replace Your DBA with a $50 hard drive.
I think I did that talk. But seriously though, if we pre-calculate that, now how often does that change? Well, it could change every single time we make a sale, fair enough. It could change every night. It can change whatever interval we care about. But if all we do is then stick 10 records in a table and then just return those 10 records, then we can do that a gazillion times. Well, we can actually do it several billion times per second on a single machine. No one's going to care. Does that make sense? It does take a bit of a, I guess, a mental, you know, thought pattern shift to just get away from the whole, but I've got lots of data, because we kind of don't.
So you're sort of saying that you'd only really store one persistent copy that you really care about. So you have like a product service, which is sort of a master copy where people go in and manually insert the description.
Yeah, you might have like a catalog management application where, you know, somebody comes in, and it might be a relational database, you know, where you can organize the category structure and hierarchy and whatever else, and then go, yeah, cool, because, you know, generally in a big system you don't have, hey, look, we make this change to a product, hit save, and, you know, it might be, hey, look, our catalog as of the 30th is going to look like this, so let's kind of publish it then, or, you know, you might publish it, here is a catalog version.
So then I guess if you had like a wish list service, if you added a new item to your wish list, you might publish an event to say add ID this, and then someone has to go and find the title and then store the title in that service.
You would probably store, hey, look, I care about, you know, when you store, like if you had a wish list service, you would probably store enough information, enough metadata to make that wish list service self-contained. And that's the thing. So a lot of people kind of think SOA, and they end up with all these things that make these SOAP calls to each other, so everything knows about everything else. You go, look, oh, I just store the ID, and I'll go ask the catalog service for the data, and all of a sudden everything knows about everything else, and you don't have loose coupling. And then the answer to that is BizTalk, because you can stick that in the middle, just ask BizTalk, and BizTalk will go find it.
Who knows what an N+1 query is? Okay. Who wants to do N+1 web service calls to do a left join on product ID to product name?
Yeah, so instead, because storage is cheap, we go, hey, look, for wishlist service, you know, it might store, you know, its own version of the catalog, so that you can just say, hey, look, user number 37 cares about this book, and then you kind of store that. And then when user 37 logs in, hey, look, give me my books, and says, look, here you go, here's the metadata about your book. So you might do that, but yeah, basically you want to store in these services enough information that they are self-contained and
And is that what the events look like as well?
Sorry?
The events that you publish?
Yeah, so the event, like if you were building the wishlist service, the event might be, it may be, hey look, we've made this change to our catalogue and now it looks like blah, and then, I've added this book, domain-driven design, to my wish list, and we saw that thing. Or it may even be, I've added domain-driven design to my wish list, and we store all of it then just under me because it's a whole bunch cheaper to, it's a whole bunch quicker to have a whole stack of sharded wish list databases. So when I just say, hey, look, I may give me my book list and it goes here they are. Not quite sure how I'd model that.
How do you manage the ID that you have between the two systems?
They start to matter a little bit less. But you could have a common ID that comes from somewhere. Say, hey, look, if the master ID of this thing lives in the catalog management service, you could populate, like, look, we've got this book with this ID. What we're not worrying about so much is, self-incrementing or auto-incrementing ID. So if I insert book number 3 from over here, into this database over here, then it becomes 7.
Well, you give it.
Yeah, give it data.
Or if it's not your data.
But it's not, that's the point. I mean, a lot of these things are like greenfields, you get to build your own application. They're all microservices. But most of the time, half of the systems are actually off-the-shelf products.
That's actually where microservices tend to shine.
Yeah.
So we're sort of looking at this as a greenfields example because it's simple to conceptualize. But in reality, we very, very often start bolting on microservices to existing horrible legacy, many, many decades old brownfields apps because it's actually an easier way to do a lot of this stuff.
Yeah, and there's a couple of ways. You could have the service that manages the integration with this old thing. You might do some mapping. Look, this product ID or whatever ID in the new world matches this ID in the old world. So when you say, hey, look, give me what's relevant to this, it can, pull it out.
Like this talk map?
I see what you said.
I'm going to come back to that because there's a fundamental difference.
Yeah, I mean, yes, you can map IDs. If you're integrating something legacy, microservices do work really well with legacy integration because you can say, rather than every one of these apps in my little ecosystem having to know about this obscure API, you can put a service around that and communicate that way. And it might be, one of the ways that I've seen this work really well is just an example that I've seen really recently was a timesheeting app. Which wasn't legacy, it was, hey look, we don't have the capacity to build a timesheeting app. There's this software as a service timesheeting app over there. We'll just use that. And in that, they needed a list of like product codes and job codes to create timesheets against. So what they did was build an integration service to that. And it would listen to events from about 3 different source systems. There was a finance system and some other work management system for different parts of the business, and they would publish, hey look, there's this new project added, and it has this job code, it's called this. And those different systems, I'm simplifying a little bit, but essentially these different systems could publish the same message, which is say, hey look, this new project got added that you can add timesheets to, or this thing got updated. Those messages went on the bus, and then we've got a service that handles integration with that SaaS app that can say, hey look, a new thing came in, I'll go sync it. A new thing came in, I'll go sync it.
Keep it open now.
Does that make sense? Yeah. Another one that I've used,
it's behind the door.
It'll get cooler if you leave the door open now. I just shut it before.
Another one that I've used, which is a really ugly bolt-on, but it was brutally efficient, was wrote a little thing that went it's brutally efficient, and so I'm not proud of it, but it worked really well. It's like a legacy system that a whole bunch of things touched the database of, and there was no API that could get to. So I basically went, right, when this table changes, publish this event. And it would be kind of take database activities, stick them in a queue table, which then got published onto a bus. So I could say, right, when this thing, like rather than all these services have this kind of long tail cache invalidation issue, when this thing changes, let everybody know, hey look, this item changed, so we can go and rebuild all of those.
I guess my question was more along the lines about the identifiers in different systems. Your product system might have a product ID which you might treat as the master, but it's quite easy to have another system that also has a product identifier, which actually is not that ID.
Yeah.
And you need to marry them up. And you might,
Well, look, I mean, it depends on your usage. So, you know, in the case of a wish list management service, it might be the product ID that's going to be on the website. Because ultimately, the point of that wish list management service is it's an easy reference of links for me to click on so I can go to the page and buy it. Yeah, so your wish list, your wish list system doesn't care about the ID that the logistics system knows this book. Like, it doesn't care about the ISBN code, right? All it cares about is on the website you'll find this book by going over here. So there's no one true answer to that question. It's a context thing.
It may or may not be relevant, but Azure Database Sync uses triggers.
Sorry?
So if you've got two databases on different machines, you can use Azure Database Sync, which has a trigger for every table, and then when something happens, it sends it to the Azure Cloud and then down to the other database.
Yeah, it's pretty ugly.
Yeah.
I mean, ultimately, Azure Service Bus runs on SQL Server. SQL replication is actually a message bus. There are no new ideas in computer
I
science.
think that would be perfectly valid if that was the same application.
Yeah, absolutely. If you've got a SQL server here and a SQL server here, and then the schema is the same, that's transactional replication, right?
So what was that new feature that just hit GA in Azure, the cache thing? Redis, I'm sure someone's
in the cloud.
Oh yeah, Hackathon is really, really cool. But like the fact that Redis has just hit GA in Azure now. Again, if you're looking at, well, I have a thing, I've generated some particular chunk of data, and I just want to share it across the same multiple instances of the same thing really, really fast, then absolutely do that. Use whatever native replication service works best. But the difference there is that you're not coupling different types of systems to each other. So say, for instance, that one of these web servers does some sort of calculation and shoves the result in a Redis cache. Okay, cool. All of these other web services, so web servers can probably just pull it straight out of Redis, but you wouldn't give your credit card gateway the same Redis cache key. So you'd say, look, you guys can all share this data and then we'll just farm it out. Or you guys over there should really probably obey the message contracts, and that way we can change the structure of these at any point in time we care about, and we don't impact any of the other applications or services within the ecosystem. So absolutely, if you've got just the same application but multiple instances of it, then yeah, sure, use whatever replication mechanism you want. By all means, use SQL replication through here if it's faster. Probably isn't, but there's no reason why not to use it, or at least why not to experiment with it. Does that make sense?
It's late, I think we're losing people. We'll finish up pretty quickly.
You were going to say something.
Fine. Let's say it for the
We'll be around to leave it out.
There's a couple of different schools of thought on how to do microservices. The ThoughtWorks crew really like REST.
Sorry.
I said to put that together.
Apples versus oranges.
Look, it is and it isn't. An asynchronous message bus, I think, is a better way to do it, because you don't need to know about the endpoints of other things, and you can kind of get that kind of, competing queue stuff working really, really well. Other people like to use more REST things. I'm not going to get into it.
But you can hit service bus with REST. I don't understand that premise. That doesn't make sense.
So it's more the shape of an individual service. If I have a service bus endpoint, then that's just the one endpoint. I can chuck any message type I want on that service bus. I can say, I can chuck what time is it request. I can say, give me an exchange rate. I can say send an email, or whatever it happens to be.
So you're talking about service bus as an architectural concept, not as a queue.
But the service bus, as long as I can get to that bus, I can say, here's a message. Make it go wherever it's supposed to go. Contrast that with the WCF or REST or just HTTP or whatever flavor service. You kind of have to know, either you end up with one gigantic request broker, which then has to know
Which is what service bus is.
Well, yeah, except service bus is full REST. Service bus is full REST. I connect to a thing and I tell the service bus, hey, you can give me some stuff. I don't get stuff pushed via some sort of load balance or request broker or anything. So where you're looking at using HTTP, what tends to happen is you have a lot of endpoints, and usually you have an endpoint per service. And then what that means is, oh bollocks, we've just added another service. All of a sudden, everybody in our ecosystem now needs to know about that new endpoint. So I just moved my exchange rate calculator from here to over there. And I've kind of violated my single responsibility principle, and that all of my other apps in my ecosystem have to change. They've got their own reasons to change, but now I've just artificially introduced one. And we've seen one particular client, they've actually given up on doing web.config transforms because they have so many SOAP endpoints that it's just all too hard. They've got something like 50 different SOAP endpoints, and every single time they add a new one, it's just scary. So they've just gone with machine.configs and they're just copying stuff around the place. Whereas your service bus approach, you can basically say, look, I've got my production instance of a service bus, I've got my UAT, if you must have UAT, I've got my nightly, I've got my CI, I've got my local development instance, but it's only one connection string in the same way that I've got one database connection string in that instance, and the service bus will broker all of the messages for me, so that's the only thing I have to configure.
So you could be with REST, you'd have to have some kind of service in front of the thing that knows about which are up and which are down and when you add them, right?
You're going to have a load balancer per service. Yeah. So a load balancer per REST endpoint.
So shouldn't it say service bus versus point to point though? Because the REST is just an implementation protocol, right?
Yeah. REST is state.
If you like doing this stuff on Azure Service Bus, we put a shameless plug, which is, that's our logo.
I agree with that.
If anyone's seen this talk before, Azure Service Bus is great. The API for connecting to it is pretty low level. It's like every line of your application code opening up a new SQL connection and running a select statement. We've got a nice programming layer on top of that, which we're going to talk about a bit more tonight, but we talk too much.
Nimbus, you should totally look at it.
Yeah, Nimbus API on Twitter. The other thing is I have to put a bit of a plug in. If you're doing this stuff and you've gone from deploying one app to deploying lots and lots and lots of apps, you want to automate the hell out of that, or you're in for a bad time. And if you want to do that, use Octopus. That paid for me to be here. It's 8 o'clock. Thank you very much. If anyone's got any questions, we're around.